let's talk about the derivatives of trig functions. So essentially, they are all right here. All the derivatives are right here. So the derivative of sine, oh boy, that's way too big, is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cosecant is negative. So negative cosecant cotangent. Before we get to that one, let's look at a pattern here. Derivative of tangent is secant squared, and then derivative of cotangent is cosecant squared. So tangent, secant, and cotangent, and cosecant. So tangent is related to cotangent, of course, and secant is related to cosecant. So their derivatives are are kind of related. Negative cosecant squared. And then if you look at cosecant and secant, the derivative of cosecant and secant, those contain a product of two of the other functions. So where do these come from? Well, if you look, let's talk about sine and cosine. If you look at the derivatives of sine, so all these tangent lines here are going to give you the values of these tangent lines give you another function. And that other function, if you look, they're positive here, 0, and then a negative. That's the slope of the tangent lines. So where it's positive, the derivative, so this down here is the derivative. Where it's positive, the slopes are positive. The function's going to be positive. And then where the slope is negative, which is all right here, the graph is negative, all right there. And then we can do this again if you want, where it's negative over here, the graph is negative down there. And so let's erase all this now, when you look at the graph of sine, you notice that it's essentially just cosine. So this one's cosine of x. This one's sine of x, so the derivative of sine x is cosine x. Well, how do you prove that? Well, we're going to prove it in a minute. Let's just do some problems using these functions, and then I'll show you the proofs after the fact. So, for example, you may have something like y equals, let's say, I don't know, sine x times cosine x. So then y prime will be, so we got the product rule. This is f and g. So it'll be f prime g plus f g prime, which would give you the derivative of sine is cosine. So you get cosine of x times g, which is just cosine of x. The derivative, and then plus f. F is just sine of x. And then g prime. G prime, the derivative of cosine is negative sine. So we're going to put a negative sign there. And by putting negative sign, we can make this a sine x here and make this a negative now. And so we get cosine squared of x minus sine squared of x. Now that looks awfully familiar. This is just cosine of 2x. And it turns out that when we get to the chain rule, we'll see how these two are related. All right, so there you have it. The other derivatives, let's do one with secant in it, secant tangent. So if you have something like, for example, oh, I don't know, let's say h of x is x secant of x, then h prime of x, this will be f and then g. H prime of x will be derivative of f, which is 1 times g secant x. So it's f prime g plus f g prime. And then plus x, which is just f, derivative of g, derivative of secant is secant tangent. Secant tangent. I need you to memorize these. Yes, you need to memorize all of these guys. Sorry, I'm going all around the whole thing here. Yeah, so derivative secant is secant tangent. All right, let's look at some problems that you might see in the WebAssign. So this is number 26 in the book. similar to one of the web assigned problems. So you have a curve here, and you have the curve is defined at a certain point. We have to find the tangent line to the curve. So the tangent line, we need the slope of the curve at pi over 3, comma pi plus 3. So apparently if you take pi over 3 and you plug it into this function, you get pi plus 3. So every time you see tangent line, you're going to take derivatives. So we do y prime is, let's see, let's write down what y is. Y is 3x plus 6 cosine x. Or y is 3x plus 6 cosine x. So we'll take the derivative, so that's 3 plus 6 times negative sine of x. Derivative of cosine is negative sine. So we get 3 minus 6 sine of x. And then the slope at pi over 3, y prime at pi over 3, will be 3 minus 6 times the sine of pi over 3. So sine of pi over 3 is root 3 over 2. So this is 3 minus 6 times root 3 over 2. So this is 3 minus 3 root 3. And there you have it. So that is the slope that we need. Now we just need the point. So let's go ahead and find the tangent line at the point. So it'll be y minus pi plus 3 equals m, which is 3 minus 3 root 3 times x minus pi over 3. These are probably numbers you're not really used to working with, but it doesn't hurt to see something like this every once in a while. We need to FOIL this out. So that'll be 3x minus pi minus 3 root 3 x plus 3's cancel pi root 3. All right, so I'm going to simplify this. Okay, so I did some of the math, and this is what I got right here. There's my tangent line. So what I have here is the slope, and right here is the y-intercept. So what I did was I went ahead and plotted this in Wolfram Alpha, and I got right here. And so we see that basically this is our pi over 3. Pi over 3 is similar to 3.14 over 3, so it's similar to 1. So that's at 1, we have our tangent line, and we see that it is indeed, this line right here is indeed tangent to, this is our function, this is that function 3x plus 6 cosine x, and it is indeed tangent to it. And then this guy right here, this little y-intercept, that's 3 plus pi root 3. All right, so that's that problem. All right, so what I did was I pulled a couple out of the book. So this first one here is f over g, notice. So the derivative of that is going to be our f prime g minus f g prime over g squared. So when we do that, the derivative of sine is cosine, that's the top one, times the bottom, 1 plus tangent of t, minus comes from here, the top one, times the derivative of the bottom one. Derivative of 1 is 0, the derivative of secant squared. So secant squared tangent all over, and now 1 plus tangent t quantity squared. That's your g squared there. And now if we want to simplify this, we're going to get cosine t. Now if you notice, cosine and tangent, these two will cancel into just sine, because sine of t comes out of it. It's cosine t times tangent is sine over cosine. And so these will cancel, and so you'll just get a sine out of that. And so you can simplify this a little further to give you cosine t plus sine t. Let's see what happens here with these two. Sine t times 1 over cosine squared of t, sine of t, and then sine squared, sine over cosine squared. I don't really think that's going to help us any. There you have it, or any iteration of that. Now I want to go back to this other problem. This one right here, theta, cosine theta, sine theta. That is an unusual problem. F of theta is theta, cosine theta, sine theta. So what you have here, theta is your variable. That's like your x, okay? So when you take the derivative here, you kind of have to notice that there's three functions here. So I'm going to call this one g and this one f. Well, let me rename the function h because f is busy. So h prime will be f prime g plus f g prime. So h prime will be f prime, derivative of theta will just be 1, just like the derivative of x is 1. So I have 1, and then cosine theta sine theta, plus, and then theta, and now the derivative of g is itself a product. So it's fg. So I'm going to do f prime g, I'm going to capital F and g, plus fg prime. So we'll get f prime, derivative of cosine is negative sine. So negative sine times sine will give you negative sine squared of t. And then times, so plus f, which is cosine. Now the derivative of g is sine, looking here. So I write cosine theta, the derivative of sine is cosine, so I get cosine squared here. So out of all this, I get cosine theta, sine theta, plus, all right, now this here is cosine squared minus sine squared, which is cosine of 2 theta. So this is theta times the cosine of 2 theta. And there is the answer. Now, you can simplify this more by noticing that, remember that sine of 2 theta is 2 sine cosine. So if I divide both sides by 2, I get 1/2 sine of 2 theta equals sine cosine, which is right here. All right. So what I can do is write that as 1/2 sine 2 theta minus theta cosine of 2 theta. And there you have it.